All right, welcome to our video on polynomial inequalities. There is a warm-up of 2 problems to start. You can go ahead and pause the video and try those 2 on your own. All right, let's see how you did. I'm going to zoom out here so you can see those. If you got those answers, let's move on. If not, pause the video and try to figure out what you did wrong. Okay, so what we're talking about today is polynomial inequalities. So I'm going to fast forward through these problems really quickly so we can see what we're looking at here. So this is a polynomial inequality. This is a polynomial in factored form. So if you look on the left-hand side, you see factors. On the right-hand side, you see 0. And it doesn't matter which side the 0 is on, but I'm just saying that, right? So this is a greater than or equal to. The polynomial is greater than or equal to 0. Okay? This right here, factored form. All right, left-hand side's factored, 0 on the right-hand side. This is not in factored form, but we're going to need to get it in factored form. You'll see why as we move through these. This is not in factored form because it's not equal to 0 in factored. And this is also not in factored form. So some of them will have to get in factored form, some of them are not, but they're all polynomials, right? Okay, so this right here is telling us how to do this. So with our polynomials, they're either going to be greater than or equal to 0, greater than 0, less than or equal to 0, or less than 0, okay? So it's going to be similar to a process that we've done before, but before, I'll explain as we go. Okay, so step number 1 is what you're going to do is you are going to find the zeros or the solutions to the polynomial. So in order to do that, it has to be an equation. So we're going to imagine that it's an equation, and we're going to solve it. These are called our critical values or our zeros. Okay, and when I say or, I mean like you can refer to them as either or because your critical values are your zeros. So basically what we're going to be doing is, let's say I have, this is an x and a y axis right here. We are going to find where the function hits the graph. So let's say it hits in those 3 places. We're going to find those 3 values. Okay, and there can be 5, there can be 1,000, or there can be 1, whatever. Okay. So next what we are going to do, we're going to create a sign chart with those values on it. So a sign chart we've done before. So on a number line, you're going to put those 3 values. You're going to decide if you're including those values or not. If it's greater than 0 or less than 0, we're not including those values because I don't want to know where it's equal to 0. Okay? If it's greater than or equal to or less than or equal to, we want to know where it's equal to 0 also, so those 3 values would be included in your solution. Next, and we'll also know where these numbers are. So let's say that this is -4, -2, and 3, okay? Next, what you're going to do is you're going to test a number on each interval to see whether it gives you a positive or a negative output. We've done this before. So let's say I get positive, negative, negative, positive, okay? And then lastly, you're going to write your solution. So before when we were doing this is what I was referring to before, these were all underneath the square root, and we were always looking for where it's positive. Right? We're always looking for where it was positive. That's not necessarily going to be the problem. So if you look at this one is greater than or equal to 0, but this one's less than. So if this was the problem, then we would be choosing all our negative solutions. We'd be choosing all of these. If the second one, or the first one was the problem, we'd be choosing all our positive solutions. So these would be our solutions. You just gotta look at what they are and then write it in interval notation. So that's the gist, okay? So here's our first problem. Let's go ahead and walk through this. It's going to take a while to do the first problem because I have to explain every single step as I go. But please know that there is a shortcut, okay? And I am going to explain that shortcut to you. So the first 2 problems I'll do algebraically in case you don't understand the shortcut. But then after that, I'm going to be doing the shortcut because why wouldn't I do the shortcut, right? Okay. So we're going to solve this polynomial inequality. So as we're solving this one, I actually would like to show you what it looks like so that you can see what we're actually doing here. Whatever. Clear. I got my new iPad update, so sorry. Don't worry, just be patient with me, please. I want to multitask here for a second. And I'll just show you what it looks like. Okay, so let me get my Chrome open. Chrome, come over here, please. Chrome, come over here, please. Yep, I'm not starting over just because it's not being nice to me. All right, y equals, I already put it in there. Smart, I know. So this is what it looks like. So things that you should see here is that it hits the x-axis at -2. It hits the x-axis at 1, and it hits the x-axis at 3. right? So those are my 3 zeros, okay? I also in this problem want to know where it's greater than or equal to 0. So it's equal to 0 at -2. It's equal to 0 at 1. It's equal to 0 at 3. So those are going to be part of my solutions. And then I can't point to it or circle it, but that on the right-hand side of the graph where it's above 0, that's where it's greater than, okay? Which is in between 1 and 3, I believe. 1, 2, 3, 4. I can't tell by looking at in between 1 and 3, I can tell. So I already know what the answer is. It's -2. And all values in between 1 and 3, including 2. I know that that's what the solution is going to be, okay? But how do we get that algebraically? Because we're not always going to know what the graph looks like, okay? So let me show you how to do that. So first off, you need to find your zeros. This is already factored for me. So I'm going to set each factor equal to 0 and solve. Each factor with an x in it, that is. I'm not going to set -1/2 equal to 0 because there's no x in it. So we get 3 critical values. X equals -2, x equals 1, and x equals 3. So there's that -2, 1, and 3, which is, we know that that was part of our solution set, right? We're going to put those on a number line, -2, 1, and 3. We're going to decide if those are part of our solutions, okay? So you look at your inequality symbol. This is greater than or equal to 0. So we do want to know where it's equal to 0. It's equal to 0 here, here, and here. Okay, so far we have those 3 solutions, okay? Now we have to know, are these solutions also? Are these solutions? Are these solutions? Are these solutions? Right? We need to know if we're including those. So we are going to pick a point and test it in each interval. So I'm going to start by picking an value on this interval right here. So a number less than -2. I'm going to do x equals -3, and I'm going to test -3 in this inequality, okay? You don't need to know the exact answer. You just need to know if your answer is positive or negative. So we have a negative. I'm just going to write this down because otherwise I'll forget. A negative times, if I plug in, oops, I wrote it down and then I erased it. Then we're going to plug in -3 here. -3 plus 2 is -1. -1 squared is a positive. Anything squared is a positive. Plug in -3 here. -3 minus 3, sorry, -3 minus 1 is -4. Cubed is a negative. And then plugging in -3 here, I get -3 minus 3, which is a negative. So I have a negative times a positive times a negative times a negative, which is a negative. So those are all values that are below the x-axis, or sorry, yes, the x-axis. So those are all values where y is less than 0, not part of my solutions, okay? Now I'm going to test values in here, so I'm going to do x equals 0, okay? So plugging in 0, I still get that -1/2 no matter what when I start, so that's negative. And I'm going to plug in 0 in those 3 places again, okay? So plugging 0 in here, this is something squared, so I always get a positive no matter what. 0 minus 1 is -1. -1 cubed is negative. 0 minus 3 is negative. So once again, negative times a positive times a negative times a negative is negative. Those values are less than 0, not included in my solutions. All right, now I'm going to test a value in between 1 and 3, so I'm going to choose 2. Long explanation, I know, for the beginning, but if you're like, I got it already, this is great, right? So I'm going to do x equals 2. I get that -1/2 no matter what, and then 3 places to plug it in. This is always positive because it's something squared. All right, 2 minus 1 is 1. 1 cubed is positive. 2 minus 3 is negative. So I have 2 negatives this time. That gives me a positive. Those values are greater than 0, which I'm looking for, greater than or equal to. So those are included in my solution set. And then lastly, a number bigger than 3. I'm using 4. I get that negative no matter what, that positive no matter what. I just really got to test those 2. 4 minus 1 is 3. 3 cubed is positive. 4 minus 3 is 1, which is positive. A negative times 3 positives is negative. Okay, now just to go back and say, what values am I including? Am I doing less than 0 or greater than 0? It's or equal to, right? I'm doing greater than, so I choose these. And now I'm going to write my solution set. So I have -2 as a solution, right? So how do I include -2? I put brackets around it. Union, and then I want to say all values in between 1 and 3, including 1 and including 3. So there is my solutions in interval notation, okay? Now, if I wanted to write this in set notation, like I could say x is equal to, and then you can say -2, comma, and if I wanted to put this in interval notation, I can do 1, 3. That's another way of writing it. And then there's also inequality notation. So you would have to say x equals -2, and then all values in between 1 and 3 would be 1 less than or equal to x less than or equal to 3. This is what our lesson is on, is interval notation, so this is the way I'll be writing it. Okay, let's talk about that shortcut, okay? So the shortcut saves us by us not having to do this, this, or this. Just, it only has to do one. I'm gonna do 0. Why would I not do 0? It's the easiest math for me to do, okay? So if I plugged in x equals 0 and I got this, and I knew that these were negative values, I can get the other 3 by using multiplicity, okay? Multiplicity is the number of times the factor of that 0 appears, okay? So if you look at this 0, it's -2, right? You're gonna look at the factor that comes from. This is the factor that it comes from, and its multiplicity is 2. If the multiplicity is even, the sign doesn't change as you move to that, over that 0. So this means that would be the same sign, which is negative, okay? This 0 comes from this factor. Its multiplicity is odd. If it's odd, then it does change. So if you look, that goes from a negative to a positive. Then I look at this one, 3, it's odd, so the sign does change. It goes from a positive to a negative. If you're like, what just happened? I don't know, I don't understand that. Then you can do it this way every single time. Okay, all right, let's try another one. We're gonna do it by the long way, air quote, but it'll be a little bit faster. And then I'll just do the shortcut for the rest of the notes, okay? So first off, finding your zeros or critical values, set each factor with an x in it equal to 0 to find those. So I have x equals 0, x equals 5, and x equals -2. I'm gonna put those on a number line. So we have -2 comes first, then 0, then 5. I'm going to decide if they're part of my solution set. It says values just less than 0. I'm not including my zeros. It's not less than or equal to. So these are all open points. So these are not part of my solution set. So I'm going to have parentheses on my answers no matter what. No brackets, right? Okay, so now I'm going to check a value on each interval. I'm going to start by checking x equals -3. So if I plug in -3 here, here, and here, I have to say what I get. So I get -3 for the first one. -3 minus 5 is -8. I'm squaring it. That's a positive. -3 plus 2 is a negative. A negative times a negative times a positive is a positive. So those values are all positive right there. Okay? Now I'll pick a value in between -2 and 0. So I'll do x equals -1. Plugging in -1 in the first spot, that's -1. I'm squaring something in the second spot, so that's automatically positive. -1 plus 2 is positive, so that's going to give me negative solutions. X equals 1 is in between 0 and 5. I plug in a 1. My second value is always positive because I'm squaring it. 1 plus 2 is positive. This is a positive number. So those are positive. And then a number bigger than 5 is 6. So I get a 6. That's a positive number. And this is always positive and positive. So I have negative or positive solutions, then negative, then positive, then positive. So now look at your inequality symbol. Okay, your inequality symbol says I want where the function is less than 0. Less than 0 are negative values. So these are my solutions. If it was positive values, it would be the other 3 sets. So I write my answer in interval notation, -2 to 0. Got it? Okay, now let's look at the shortcut way, okay? Just pick one of your values, okay? Let's say I picked x equals 1, okay? And then I wouldn't have to do that other work right there. And I would look to see what happens, okay? So I want to know what happens here. At 5, it has an even multiplicity, so I would keep the sign. Here at 0, it has an odd multiplicity, so I would change the sign. And at -2, it has an odd multiplicity, so I'd change the sign again. Okay, so I'm going to do it that method, and hopefully if you're like, I'm having trouble following that, hopefully you'll follow it on the next one. If not, the way that I have been doing it is the way you should be doing it. Okay, number 3 It is not factored for us. It's already equal to 0, which is good, but it's not factored for us. Let's go ahead and factor that. We need two numbers that multiply to give us -8 and add to give us 2, which is x plus 4 times x minus 2, and then less than 0. All right, we are going to find our critical values are our zeros, which is x equals -4 and x equals 2. We're going to put those on a number line. -4, 2. Your inequality symbol is less than, not less than or equal to, so -4 and 2 are not included in our solutions. So now instead of picking 3 values to plug in, we're just going to pick 1. If 0 is a possibility, that's the one I pick. So I'm going to do x equals 0, which falls right here, so that's the sign I'm going to find. So plugging in 0, I get, you can either plug it in here or here, right? But it has to be a 0 on this side to actually do what we're doing, okay? I'm going to plug it into the factored form because it's easier for my brain. If I plug in 0, I get 4 times -2, which is a negative. So this is negative. And now I'm going to use that shortcut to get the other two signs. You're going to look at the multiplicities. The multiplicities are both odd. So to go over, to jump over the 2, you're going to change the signs if it's odd. To jump over the 4, you're going to change the sign if it's odd. Now look at your inequality symbol. I want to know where the values are less than 0. Less than 0 are negative values. So my solution set is -4 to 2. Not including -4, not including 2. So notice the shortcut is a very big shortcut. All right, this one, at first glance, it looks like it's in factored form, but that's not a 0 on that side. So this is not in factored form. So to get it in factored form, let's go ahead and expand it first. That's x squared plus x is greater than or equal to 20. Now get it equal to 0. Actually, we just get it equal to 0 in the same step. Subtract 20 from both sides, and now it's in standard form, right? Now that it's in standard form, we can factor it. We're looking for two numbers that multiply to give us -20 and add to give us 1. So we have x plus 5 times x minus 4 is greater than or equal to 0. So we're going to start by finding our critical values, or our zeros. X equals -5 and x equals 4. We are going to put those on our number line, -5, 4. Look at your inequality symbol to see if you're including those in your solution sets. We want greater than or equal to 0. So here's where it's equal to 0, -5 and 4. So those are part of our solution set. Excuse me. Now we're going to pick a point to test. I'm going to use 0 again. So I'm going to do x equals 0. 0 falls right here, so that's the sign that I'm getting, okay? So I'm going to plug in 0. I'm going to plug it in here because it's make sure one side's equal to 0, but the factored form's easier for me. 0 plus 5 is 5. 0 minus 4 is 4. 5 times -4 is a negative. So these are negative values. And then if you look at your multiplicity, they're both odd. So as we jump over the 4, we're going to change signs. If we're going to jump over the -5, we're going to change signs. And now look at your inequality symbol. Your inequality symbol is greater than or equal to, so those are positive solutions. So I want these and these. So now I'm going to write my answer in interval notation. It's -infinity to -5, including -5, so I'm using a bracket, union, 4 to infinity. All right, one more in this section, I believe, and then we'll move on to it worded in a different way, but still, we'll be fine. All right. So we need to find the zeros. In order to find the zeros, it has to be equal to 0, and then we have to factor it. So we have x to the 4th minus 4x squared is less than 0. We need to factor this. So two terms, we're looking for a GCF of x squared. And then we have x squared minus 4 less than 0. It's still not factored yet, so let's completely factor it. Like it is started to be factored, but not completely. That's a difference of squares, so x plus 2, x minus 2, less than 0. Okay, so now we want to get our critical values, set each factor equal to 0 and solve. We get x equals 0, x equals -2, and x equals +2. And if we're going to use our multiplicity trick, this does have to be broken up, all right? All right, put those on a number line. Okay, look at your inequality symbol. It says less than, not less than or equal to. So we're using open points. Those are not included in our solution set. I can't pick x equals 0 because 0 is a 0, right? So I have to pick a different number. So I'm going to pick x equals 1, which would fall right here. So that's the one I'm finding. So plugging in 1, I have 1 squared, which is positive, times 1 plus 2, which is positive, times 1 minus 2, which is negative. So that's going to give me negative solutions. Okay, so now I'm going to use the multiplicity to get whether the other ones are positive or negative. So here I'm jumping over the 2. If you look at the multiplicity on the 2, it is odd. Right, and remember, make sure you're looking at the factor of x minus 2 for that. So odd, change the sign. This next one is 0. So I'm looking at the multiplicity as I jump over 0. 0's multiplicity is 2. So that's even, so I'm going to keep the sign. And now I'm going to look as the multiplicity as I jump over negative 2, which is a factor of x plus, oops, I did the wrong one. Oh no, that's right, x plus 2, because that's the negative 2. And it has a multiplicity of 1, which is odd, so I'm going to change the sign. So that is what we're looking at. Now look at your inequality and see what you need. You need less than 0, so your negative solutions. So these and these. All right, so let's write our solution set in interval notation. So those are all solutions in between negative 2 and 0, not including negative 2 or 0. Union, all solutions in between 0 and 2, not including either 0 nor 2. Okay? All right, so the next problem is using this same idea but in words. So you just have to make sure that you can write the inequality. So this says consider this function, solve for x when the function is greater than or equal to 0. So let's make the function x squared minus 3x minus 10 greater than or equal to 0. All right, same idea now. Factor it. X minus 5 times x plus 2 greater than or equal to 0. X equals 5. X equals negative 2. Number line. Negative 2. 5. Look at your inequality symbol. These are included in our solution set. Pick a value. I'm going to do x equals 0, which falls directly in between right here. Plugging in 0, I get a negative times a positive, which is a negative. These both have a multiplicity of 1, so as I jump over that 0, the sign will change. The inequality symbol asks me for values greater than or equal to 0, so I'm including the ones that are greater than here. And then I can write my solution set. Negative infinity to negative 2, bracket, union, bracket, 5 to infinity. Okay, looking at the next one. Consider the function. So this is not even a polynomial, so it doesn't necessarily fall on this, but we've done these before, right? So it says if you look, this is a square root function, which is not a polynomial. Find the domain of f of 3x minus 5. So remember what that means. If I said find f of 2, you'd plug in a 2. F of 3x minus 5, plug in 3x minus 5. So we're going to replace this x with the 3x minus 5. And we get the square root of 3x minus 5. And it wants us to find the domain of this, which we've done before. This is a square root function. We know that we cannot take the square root of negative numbers. So we're going to say that the radicand has to be greater than or equal to 0. It could be positive or 0. Solve this, add 5 to both sides. 3x is greater than or equal to 5. Divide by 3, we have x is greater than or equal to 5/3. Then we can write that in interval notation. So 5/3, the bracket on it because we're including that, through infinity. So didn't need a number line for that one because we can think through that one very easily. We can picture that. All right, this one, find the domain of x squared minus 2x, of f of x squared minus 2x minus 8. So same idea, but we're going to plug in that, x squared minus 2x minus 8. Same idea, this must be, the radicand, when I say this, must be greater than or equal to 0, right? It could be 0, but it's got to be positive if it's not 0. So we're going to say x squared minus 2x minus 8 is greater than or equal to 0. And then now this is what we've been doing the whole period, right? Factor it. X minus 4 times x plus 2 greater than or equal to 0. Critical values, 4 and negative 2. Put them on a number line. Negative 2 comes first, then 4. Pick a value anywhere. You know what I'm picking. And 0 doesn't always fall in the middle. It just so happens where every factor that I've had. All right, negative times a positive is a negative. That means these have multiplicities of 1. So this is positive, this is positive. I forgot to say that I'm including negative 2 and 4. And then you want greater than or equal to. So these. So my solution set is negative infinity to negative 2, bracket, union, 4 to infinity. Hopefully you're seeing some connections to what we did last chapter with this chapter. All right, lastly, it says write a polynomial inequality that has the following solution sets. So this is just working backwards. This is the solution. I want you to tell me the inequality. Okay, so if we're working backwards, we're going to start with drawing what this looks like. So we have negative 6 to 1. You're not including negative 6. You're not including 1, but it's all values in between. So knowing that, I know that negative 6 is a 0. I know that 1 is a 0. If negative 6 is a 0, then that comes from a possible factor of x plus 6. Obviously, it could be like 2x plus 12, but let's not get crazy, okay? Then we have the 0 of 1, so x minus 1 is a factor. This is what we're figuring out, right? That inequality symbol, and then 0, right? So we need to know, are those positive values or negative values? We know that we're not including negative 6 and 1, so it's not or equal to. We just have to figure it out, okay? So let's go ahead and finish our sign chart, right, for this. So pick a value anywhere. I'm gonna pick 0, I'm gonna do x equals 0, and we're gonna plug 0 into our factored form right here. That's a positive times a negative, which is a negative, in a multiplicity of 1 for both, so this is positive, this is positive. So if you look, these solutions right here are our negative solutions. Negative solutions are values less than 0, okay? So the last thing that we want you to do is just write it in standard form, okay? So, and I'm actually fine with that, but x squared plus 5x minus 6 must be less than 0. I have to look back at the test and see if we tell you to put the polynomial in standard form or factored form. But just to be safe, let's make sure we know how to put it in standard form, right? All right, last one, okay? Once again, I'm gonna start by saying this is what it looks like on a number line so I can start to think here. So here's 2 closed, values that way. 5 closed, values that way, okay? So if 2 and 5 are zeros, I know x minus 2 and x minus 5 are possible factors. I need to know what this is compared to 0. I know I'm including them, so I'm going to put the or equal to sign already. I just need to know if it's less than or equal to or greater than or equal to. All right, pick a value. I'm going to pick 0, which falls here. Ooh la la. Plug in 0 into your equation. That gives me a negative times a negative, which is a positive. So that means that that's positive. And then if you look, our multiplicity for each is 1. So as we jump over this, sign change. As we jump over that, sign change. If you look at our shaded values, the ones that we are included, those are positive. Positive is greater than. So greater than or equal to. Lastly, just multiply that out to have it in standard form just for good practice here. Oops. And there's your solution. All right, that's it for today. Hopefully that you got through today's notes and now you can start on the homework.